is a way to get payloads to space. It's very viable. The Japanese are getting ready to launch another HTV here in January, and then ESA will launch an ATV in February. So as we transition out of the shuttle era into the new era, we have ATV and HTV to bridge that gap. We have new commercial companies coming online, both Orbital Space Corporation and SpaceX are both working to bring cargo to space. SpaceX has a large trunk behind a Dragon capsule that can carry external payloads. So there's a fair amount of up mass that's available for this research community. So again, the challenge for us is to find things that we can get to space, get them quickly, utilize these variety of vehicles to get them there, and use the station as it was designed as a platform of discovery. On the inside, from the internal accommodations, there's four major labs. There's the Destiny Laboratory, which is basically U.S. capabilities. We have the Columbus module, which is available also for research, and then the Kibo module. And each country does, and then the Russians also have their module also for scientific payloads, and they're going to launch another module later, I believe in 2012, or I think it's 2012 now. That will also bring up some more research capabilities. So there's plenty of laboratory space on the inside. There's plenty of racks already up inside Space Station. I'll talk about those in the next couple of charts. But these facilities are already there. They're ready to house experiments. All we need to do is bring some samples up, look at new, creative, inventive ways to utilize these laboratories and move forward. So what's exciting here is we don't have to talk about or dream about what we ought to have in space. We need to take a look at what is already in space. And the challenge for us is how to take what is already in space and use it creatively and effectively to be a platform for discovery. And again, just as there were 23 external sites, there's 23 internal sites. And with 1 to 8 payload locations for each one of those. There's also some glove boxes that are available, so we can do some pretty detailed investigations in the glove box with some hazardous materials that can be still isolated from the crew and protect the crew. You can take a look and read on this chart what's available in terms of power, data. As a true laboratory facility, we have gases available: nitrogen, argon, carbon dioxide, and helium. There's cooling available to provide cooling to these racks. There's a vacuum available, so you can actually get a vacuum source from space if needed. So the bottom line here is that this is truly a world-class research facility, as good as any research facility on the ground. It happens to be located in the unique microgravity of space. So the challenge for us, and the challenge for all of us in this room, is to figure out how to creatively use that to get these unique discoveries that we need to move forward with. And it's, as Frank said, we're looking for the killer app. It's up to the folks in here to be innovative, creative, to find that application that makes sense, that can be a game changer. And it may not be a killer application, but it may show that there are some really areas of space that are truly unique. We see all our biological functions occur here on the Earth in the presence of one gravity. We know when we go to a lower microgravity, things change. We know the astronauts experience bone loss, just like the elderly do. Can we use the unique environment of space to better understand bone loss in the elderly? We also know the immune systems on astronauts also are not as effective in space. They actually degrade when they're in space. Their basic immune function becomes less effective. The same phenomena occurs in the elderly as well. Can we use that phenomena that occurs in space as another tool to gain insight to help with the elderly and immune system degradation? So we need to take the phenomena we see in the microgravity environment as they apply to things that we see in our elderly population and people here on the Earth, and look at ways to go apply that. One thing that's been going on quite a bit is we also see that we fly viruses and bacteria to space. They become more virulent, more disease-causing, but they also differentiate into a bunch of different types of bacteria and different strains of bacteria. And so then you can go in and you can select out of that one that is strong enough to cause immune reaction in the human body, but not strong enough to give you a disease. There's some companies that are working with salmonella. They've used this technique to fly salmonella to space. They get back a whole bunch of different salmonellas. Then they can pick one that's strong enough to create the immune system reaction to provide a vaccine, but not strong enough to actually give you the disease. They can then use genetic techniques to slice off the genes that give you that desirable function, and they can manufacture the vaccine here on the Earth. So that's going into FDA trials here probably in the next couple of months for actual use, and it potentially gives us a vaccine for salmonella. So what we're learning is that things behave differently in space. Can we exploit the way that they behave differently in space to have applications back here on the Earth? And that's a challenge we need to think about. But the facilities on board station are here to do all those activities. We'll talk a little bit about research on this chart. This comes from ProOrbis. We've been kind of focused in the past, I think, down in the visionary funding on the left-hand side of this screen, where we're in the theoretical area and the basic research area. That's where NASA has been focused. What we want to do with the National Lab and our surplus capability on station is open up the trade space a little bit so we can look not just at the one area, but actually look across the entire spectrum of potential research. You know, in the middle you can see some speculative funding areas. This is where there's potentially an application. I described to you salmonella. What's interesting there is that there's potentially a market for that we can get a salmonella vaccine. It turns out other bacteria behave exactly the same way. The MRSA, that's the bacteria that shows up in hospitals. It's very difficult to eradicate. It also shows the same phenomena. We can actually use the same techniques to build a vaccine or potentially control that, or at least get another therapy for that. That sits kind of in the middle area. And what these companies can do is they potentially can see this as a market. They don't understand why the phenomena occurs in space. They don't really care why it occurs in space, but they want to exploit it to generate a commercial product that can generate revenue for them. So NASA wouldn't be interested in that necessarily, but there could be, you know, venture capital. There could be other funds that a company would be interested in to go pull that and move that forward. But then in that same area, then the government can come in and say that we kind of want to understand why this is happening to bacteria or why this happens in bone loss, so then we could choose to invest some back in the theoretical research area. And we've done that in this case of salmonella. We had the University of Arizona take a look at trying to understand why bacteria and viruses behave this way. Whereas the commercial companies, they don't care why they behave this way. They're going to exploit that phenomenon in space for a commercial venture. And then out on the right is actually production areas, and that's something probably that's future to come. You know, we had talked a long time ago in the shuttle world about having manufacturing facilities in space to actually manufacture some pharmaceuticals in space a long time ago. And it turned out we found better ways underground to do that through genetic engineering. But I think there's still potential out there in the future somewhere that there could be a production capability in space. But what space station can do is it can give you this speculative kind of mid-level understanding that, hey, there's something out there that's beneficial that then warrants somebody to go off and maybe build now a commercial facility, maybe even independent of the government, independent of NASA, to go actually manufacture that particular item in space and take advantage of space. So the point of this chart is we need to think of research really as a continuum. We need to make sure that we utilize all aspects of that continuum, that we don't focus on one area at the exclusion of the others. So again, in the spirit of discovery, where can station play a role in this? Can space station help with all these areas? I think space station can clearly help in every one of these areas. So I challenge you as you have your panels and your discussions throughout the next 2 days to talk about these things and to think about where these markets are and who are we not reaching out to? What commercial companies have we not talked to that may have applications or may want to go do things in space, so we can reach beyond the typical aerospace community and reach out more into the commercial sector. So again, I gave you some ideas to think about. It's really up to you over the next 2 days to challenge yourselves to think innovatively, creatively. There's no doubt in my mind that the team that's here that helped put together this station can take that same zeal, that same energy, that same power that actually made this facility possible in space They can take that same energy and turn it into this next challenge, which is how do we utilize space station? How do we create a market in space that actually creates a pull that governments and countries want to be in space, that there is a true commercial market there that is ready to move forward. So our challenge is to move forward, to do things in creative, innovative ways, and to move forward. There's a tremendous facility in space. Since it's football season, I show it backdropped against the football field. If I was in Europe, we should probably use a soccer field. But the idea here is it's a tremendous facility, not just in size, but hopefully a tremendous facility and capability. You'll learn more about it over the next couple of days. And really make the most of this time. Spend some time discussing with your colleagues. Think about who else to talk about with this activities. Make Space Station a platform of discovery. Thank you for your time this morning.